Welcome back, everyone. This is Professor Herring. In this video, we're going to do a couple extra practice problems dealing with stoichiometry. Let's begin. Go ahead, pause the video now, and read this over and try and solve this on your own first. Then I'll walk you through a solution. Welcome back. So in this problem, we have hydrochloric acid reacting with barium hydroxide, and then the solution is diluted. We want to find out what's the final concentration of hydrogen ions. The first step for all of these problems is to write out a balanced chemical equation. Then we need to identify, if we're looking for, in the end, the concentration of hydrogen ions, what's the source of those hydrogen ions potentially? Well, it's not going to be barium chloride for sure. Barium hydroxide, you might look at this and think that it might do it because it has hydrogen in it, but remember, hydroxide is a polyatomic ion, and so it's going to stay together as such. It's not that. If there's any hydrochloric acid left over, it's definitely a source of hydrogen ions. What about water? Well, water is a non-electrolyte, which means that it's not going to produce any hydrogen ions. And that's a very common mistake that students make, is to calculate it based on the water concentration. So all we need to know in the end is what's the concentration of hydrochloric acid, if any. And the reason why is because we know that hydrochloric acid is a strong electrolyte. It's going to dissociate fully into hydrogen ions and chloride ions. So for every one hydrogen chloride molecule we have one hydrogen ion that's left over. Now that we have that down, let's try and figure out how much hydrogen chloride solution is going to be left over, if any. So we have given, we know that we have 99 milliliters of the solution and 50 milliliters of the barium hydroxide. The concentration of the hydrochloric acid is 2 molar and 0.15 molar for barium hydroxide. To find the initial moles of hydrochloric acid, that's 99 milliliters. And let's actually just convert that directly into liters. So 99 times 10 to the minus 3 liters times 2 moles per liter. And that's equal to 0.198 moles of HCl. For barium hydroxide, that's going to be 50 times 10 to the minus 3 liters times its molarity, which is 0.15 moles per liter. And that gets us a total number of moles of 0.0075 moles of the barium hydroxide. To confirm that the barium hydroxide is the limiting reactant, what we can do is we can see if we were to use all of it, how much of the hydrochloric acid would it have taken? And since it's a 2-to-1 ratio, we have to account for that. Which means that we would have, oh, this ratio is backwards. We need 0.015 moles of hydrochloric acid to react with all of the barium hydroxide. Since we have much more than that, we know that the barium hydroxide is the limiting reactant. And so it's going to get all used up. So we've already determined that we need to use 0.015 moles of hydrochloric acid, which leaves us with 0.0183 moles left over. That would mean then that the concentration of hydrochloric acid is equal to 0.0183 moles over the volume in liters, which we're told is 200 milliliters, 0.2 liters of solution. That gets us then a concentration of 0.915 molar HCl. And since we saw already that it's a 1-to-1 ratio, then that means that that's also the concentration of the hydrogen ions. So some things to keep in mind here. Areas where students often make mistakes are making the mistake of what is the source of the hydrogen ions, not checking to make sure that they're using the limiting reactant. And then there's the common errors of not putting your numbers in properly to your calculator. And then, of course, in this case, it's a 1-to-1 ratio of hydrogen ions to hydrochloric acid. But if we had something else, say H3PO4, it would be a 3-to-1 ratio. And so you would have to account for that. Okay, let's try the next one. Pause the video and try this on your own, and then come back and I'll show you a solution. Welcome back. So we want to know how many grams of propane is needed to produce a certain volume of carbon dioxide. So you would need to start this by getting a balanced chemical equation. Propane's reacting, it's burning, so we know it's reacting with oxygen to produce carbon dioxide and water. And then we balance it. We have 3 carbons on the left and 3 on the right now. We have 8 hydrogens on the left and now we have 8 on the right. And then to balance the oxygen, we need 5 in front of it. So now we're prepared to set up and look at our given information, the connection to moles, then to solve for moles, the change, and then the final. So we're looking for how much propane we would need. We're going to need grams, and so we want to use the molar mass then. The molar mass of propane is 44.1 grams per mole. And we know that we've produced 100 liters of carbon dioxide. It's at 1 atmosphere and 21 degrees Celsius. So we're going to need then the ideal gas law to connect that to moles. Moles are going to be equal to N, or pressure times volume over R times temperature, which is 1 atmosphere times 100 liters over the ideal gas law constant, and then the temperature. And you want to make sure that you convert that to Kelvin. That gets us then 4.1429 moles of CO2 was produced. Now, do we need to consider a limiting reactant? Well, we're burning. And whenever we're burning, we actually assume that we have an infinite amount of oxygen, unless you're told otherwise. So in this case, we don't have to consider a limiting reactant. So then the moles that's produced would have been 4.1429 moles. And in order to find out how much propane that was, we take 4.1429 moles CO2, use the balanced chemical equation, and that's 3 moles of CO2 for every 1 propane, which means that we would have had to have 1.381 moles of propane. To find how many grams that would be, we use the molar mass. Why do I keep writing the H instead of the 3? And that's a total of 61 grams when accounting for sig figs. All right. Now a follow-up question. Find the percent yield if the actual yield is 52 grams. Pause the video now and try that on your own. Welcome back. So percent yield is equal to the actual yield over the theoretical yield times 100%, which means then that that's 52 grams over the theoretical, which was 61 grams, times 100%, and that would be equal to 85% yield. Okay, that's it for this video. Thanks for watching. If you have any questions, you can ask on Piazza and office hours or recitation. See you later.